Math Analyzers. It is time to unravel our unit circle. I could not be more excited. So here we go. Quick review of our first quadrant coordinates at our special angle measures throughout that quadrant 1 area. Okay, so let's just kind of keep in mind sine is our y coordinate, right? I'm going to focus in on sine today, sine function graph. So at 0 degrees and 0 radians, we are at 0 as our y coordinate. We move up to 30 degrees, which is pi over 6 radians. We're at 1/2. We're kind of moving up, right? We move up to 45 degrees, which is pi over 4 radians. We are at radical 2 over 2. We move up to 60 degrees, which is pi over 3 radians. We're at radical 3 over 2. And all the way up here, our y value is 1. Okay? So what we're going to do right here is we're going to translate that into moving all the way around the unit circle. And what we're going to do is we're just going to put those coordinate y values right here, right? So at 0 degrees, our sine is also 0. At 30 degrees, our sine is 1/2. At 45 degrees, our sine is radical 2 over 2. At 60 degrees, our sine is radical 3 over 2. And all the way up at 90 degrees, we get to the top, which is 1. Okay? Now, back on through, think of it this way. Now we're going through quadrant 2. So we start with the reference angle for 60 degrees. So we're at 120. And so we're down to radical 3 over 2. But in quadrant 2, sine is still positive. So think of it, here is quadrant 1 right here. Okay, now we've started quadrant 2, which again, we've still got positive signs. So we had back down, okay, this is our 45-degree reference angle, so that's radical 2 over 2. This is our 30-degree reference angle, so we're back to 1/2. And this is back down to the x-axis, so that also means that our y value is 0 again. Okay? Now, I'm just going to copy that down here because this is where we're at quadrant 3. And in quadrant 3, sine is negative. So now, here's our 30-degree reference angle, negative, so it's negative 1/2. 45-degree reference angle, negative radical 2 over 2. Negative radical 3 over 2. Down to negative 1 at the very bottom. That's the lowest we go y-wise, is down to 0, negative 1. We're on the y-axis. Now back up towards this point right here, 0 again. So here's where quadrant 4, back up to the 360 that we know is another y value of 0. So let's move back up this direction. Still negative for all of our signs, negative radical 3 over 2, negative radical 2 over 2, and negative 1/2 to 0. This is significant because what I'm going to do is stretch this out horizontally along an XY axis to show you the curvature of the sine function. Okay, that's what we're going to do. Now, obviously, when I was just talking about degrees. Let me fill in our radians all along. So we have those going. So this is obviously also 0 radians. But at 30 degrees, we know we're at pi over 6 radians. At 45 degrees, that's pi over 4. At 60 degrees, pi over 3. And 90 degrees is half of pi, or pi over 2. We know that 180 is 1 full pi, and 360 is 2 full pies, right? So we know those particular ones. Now let's get there. So we're in quadrant 2 over here. So this is a 60-degree reference angle. So that would be 2 pi over 3, 2/3 of the way. This is a 45-degree reference angle, so 3 pi over 4. 30-degree reference angle, almost all the way there, 5 pi over 6, because it's 6 over 6 pi. 3 over 3 pi, 4 over 4 pi is all the same as 1 pi. So that's where we get to that 180. Okay, so 1 pi right here. Now head back the other way. So this is a 30-degree reference angle, right? We add 30 to get here. So that means we're over 6 again, but now we need to be greater than 6 over 6. So we're 7 pi over 6, just over that 6 over 6 spot. 45-degree reference angle means we're over 4, right? And we're just over 4 over 4. So that's 5 pi over 4. This is a 60-degree reference angle, which means we're over 3. And we're just over 3 over 3. So that's 4 pi over 3. And we get all the way down to 3 pi over 2, because there's our bottom of our circle at 270. And now back up the other way. So this is a 60-degree reference angle. That's 5 pi over 3. 45-degree reference angle. That's 7 pi over 4. And 30-degree reference angle. That's 11 pi over 6. So there's those radian measures that match those degree measures that we know. And again, we do these so frequently and have filled in our unit circles so frequently that they kind of become second nature for a lot of things. Okay. And as long as you know that reference angles, or excuse me, those reference angles, you'll be in good shape with these. So what if instead of looking at these points all along the circle, we took and stretched them out horizontally? What will that look like? Okay. What will that look like? That will look like this. What we're going to do is all along the unit circle, we're going to steal these y coordinates, which are our sign values, all along the way, and we're going to stretch them out by putting them here along a coordinate plane. That's what we're doing when we graph the sine function as y equals sine of x. What we are doing is graphing those those matching y coordinates from the unit circle all the way around. And the all the way around is from 0 to 2 pi or 0 to 360. Okay? So that's how we're going to work this. I want you to notice that here, what I'm using to go about this is going to be my 30-degree reference angles and my 60-degree reference angles. So I kind of skipped my 45s here, and that was just because of how I could fit across. Okay, so I'm skipping my 45s here. So this is all going to be my radians, and these are going to be our x values. So our x values are going to be our radians as we go. So of course, 0, 0, right? And 0 down here. Now, 30 degrees is pi over 6 radians. 60 degrees is pi over 3 radians. 90 degrees is pi over 2 radians. 120 back the other way is 2 pi over 3 radians. 150 is 5 pi over 6 radians. 180 is 1 full pi radians. Then we're back on the other direction. So 7 pi over 6 radians because of 30-degree reference angle. 60-degree reference angle. So this is 4 pi over 3 radians. We're all the way at the bottom, 3 pi over 2. 300, so that's a 60-degree reference angle. So 60-degree reference angle for 300. So where am I at? 5 pi over 3. Yep, because 6 pi over 3 would be 2 radians, right? 30-degree reference angle here, so that would be 11 pi over 6. And then this is 6 over 6, or excuse me, 12 over 6, and 6 over 3, right? So that's 2 pi radians total. And so the matches all the way. It's good to talk through this. The match is all the way 1/2, and we're in quadrant 1 up until here. So I'm going to make my notes. Quadrant 2. So here's quadrant 1. Here's quadrant 2. Here's quadrant 3. And up to here. And then there's quadrant 4. Okay. So you know where you're at and where you're positive, where you're negative. So we got 1/2. And then this is the radical 3/2. And then all the way up to 1. And then back down the other direction, radical 3/2, 1/2, and back to 0 at pi. And then over here, we're down now. So negative 1/2 and negative radical 3/2 and negative 1 at our 270 at our 3 pi over 2. And then continuing here, we've got negative radical 3/2 coming back up, negative 1/2 and 0. So back up to 0. So you can see the cycle that's occurring, the literal circle that we're wrapping or unwrapping and pulling apart. Okay, so let's consider this to be our 1 and our negative 1. So it gives us a little space. Of course, this is our 0 right here. Okay, so 0, 0 is the start. Let me just count because I got to get over to 2 pi radians. So let's say 30, 60, 90, 120, 150, 180. That's pi, right? 210, 240, 270, 300, 330, 360. Yeah, I'm going to have to go by ones. I'm not going to be able to fit all the way. So that'll work. So 30, 60, 90. I'll call this pi over 2. And I'll just do it that way. And then 120, 150, 180 is pi. And then we've got 210, 240, 270 is 3 pi over 2. And then we've got 300, 330, 360, that's 2 pi. That's plenty of space. Okay, let's unwrap. So here's half, right? 1/2. Halfway up. Okay, a little bit closer up here is the radical 3/2. So this is negative 1/2 and negative radical 3/2 right here, radical 3/2. Okay, so let's get those points up there. So up to 1/2 and then up to 3, radical 3/2 and then up to 1, then back down and then back to 0 at 180 / pi. Okay, so you can see that first hump. And that's quadrant 1, quadrant 2, here to here. Now we're going to go back negative with our signs. So these are now quadrant 3 and 4 that'll get us back up to our original starting point of 0, 0. Okay, but because we've unraveled and we've done 360 degrees, now it's 2 pi away. And so now we're back down. So here's negative 1/2 and then negative radical 3/2 and then negative 1 and then back down to negative radical 3/2, back down to 1/2 and back to 0, 0. That is the sine curve. And connect. There you go. That's the sine curve. Wow. So y equals the sine of x. Let me plug that guy into your graphing calculator. So let me make your graphing calculator a little bit larger. Y equals the sine of x. And what I'm going to do up here in Zoom is I've got this number 7 for trig. So it's zoomed in a little bit. It goes by ones and negative ones going up and down. So it gets all the way up to -1, -2, -3, -4. And then on the other side, this is going by pi over 2s. So that's why we hit right here. Use my cursor, I'm sorry. That's why we hit right here back to 0 at pi, right? And then 2 pi. Now, I just want you to note that we could also go backwards because this is a wave. So this wave ever continues in both directions. So if our circle keeps going and going and going, we then get these matching coordinates all the way around, just like we would if we continued to stretch in either direction, stretch out our circle. Okay? So that is exactly what I want you to do and to use. We're doing the basic sine function right now. Very basic, only sine, only the y coordinates that are coming from our unit circle. Okay? That's it. Just those y coordinates that are coming from the unit circle. And we're matching those on here as our y values all the way along. Okay? So again, you can see the pattern. So if I ask you to sketch the basic sine curve, okay, if I ask you to sketch the basic sine curve, so I'm kind of skipping this one right now because that's going to be what you do for your homework, all right? But if I ask you to just sketch the basic sine curve, the very basics of the sine curve get you back to 0 at pi and at 2 pi. And where you're not at 0 for the very basic sine curve is pi over 2 and 3 pi over 2, which is, of course, 90 degrees and 270 degrees. And when you're not at 0, you're either at positive 1 or negative 1. And that's the main pieces you want to keep in mind about your sketch of your sine curve. Okay? And that's it. That's really all you need to worry about. If you want to do your 45s, these in-betweens, and do your 45s, those are at radical 2 over 2, which is greater than 1/2, but a little bit less than radical 3 over 2. So you're more like up here, not half, but like more like up here or down here if you're doing it this direction. And so when we're talking about sketching, we're not getting exact, we're just kind of getting that curve to occur. And we can see the pattern of the curve. Okay, we can see that pattern that continues. It starts at 0, 0 and ends at 0, 0. This is quadrants 1 and 2, so we're staying positive. This is quadrants 3 and 4, so we had negative and come back up to the positives. This is what I want you working on. Feel free to take these notes and just copy those radian measures, copy those matching y's, because the more you do that to then make it on your homework, the better you'll be. One more, just because I have it up here and we can do this, we can look at it this direction, both directions, right? If I make this 1 and this negative 1, so I'll just do that for the time being. Remember, you start at 0, 0 for sine. At pi over 2, you're all the way up to 1. For pi, you're back to 0. For 3 pi over 2, you're down to negative 1, and then you're back up to 0 again. And in between, so if you do that halfway in between, you're about here and here. And so if you sketch this way, and then down, you're here and here, those halfways, you're kind of halfway in the halfways. There you are. If you want to take it into the negatives, like we're showing right here, and it's asking us to kind of do right here, let me just take you into the negatives. Think about it this way. You're all the way down here and coming back up, right? Just like this, you're copying from here. So then this has to be at 0 again. This one has to be up here, and then this one has to be at 0 again. And that's how you're looking for these guys. Halfway, 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 and then just kind of come back this direction. And look at that. It does look like an unwrapped circle, doesn't it? Because it is. I mean, that's why it goes together that way. So this is still y equals sine of x. Just like what we have up on our screen, right? The same exact process. So keep using that. It's the basic sine curve. We're not going to do anything to it other than to continue to look at these exact y values for this time being. Okay. Let me know if you need any help doing these. I will see you guys soon to now take cosine and do the same idea. It is going to look different, but again, we'll talk about why it looks different when we do cosine. All right, guys, good luck. Label everything. See you soon. Bye.